Okay, so we want to continue, okay, with the new subtopic, which is the resonance structure. Okay, so resonance is defined as a molecular structure with the same placement of atom. Atom placement are the same, but different arrangement of the bonding and lone pairs electron. Okay, the position of the bonding and also the lone pair are different. Okay, or it is a two or more Lewis structure for a single molecule. We have one molecule, one molecular formula. Okay, and when we draw the structure of it, it have more than one possible structure. Okay, in which that molecule cannot be represented by only one accurate Lewis structure. When we say that molecule have a resonance, so we have to have both possible structure. As example that is given here is the sulfur dioxide molecule. Okay, so there are two possible structure for SO2, in which this is the first one and this is the second structure. And the arrangement or the atom placement are the same. Okay, see the criteria of resonance, atom placement are the same among the possible structure. We have O, S, O. The second possible also O, S, O. Okay, they have the same placement of atom, in which sulfur as a central atom. Okay, but the difference between these two possible structure of the SO2 is about the position of the lone pairs and the bonding pair. Look at to the first possible structure. Look at to the first oxygen. This first oxygen has 3 lone pairs and 1 bonding pair. As for this oxygen has 2 bonding pair, 2 lone pair. Okay, so 3 LP, 1 bonding pair. This is 2 lone pair and 2 bonding pair. As for the second resonance structure of SO2, look at to oxygen 1. Okay, it has 2 lone pair and also 2 bonding pair. As for the second oxygen, it will have 3 lone pair and 1 bonding pair. So the difference between these two is just at the position of the electrons. Okay, when it has 3 lone pairs, the bonding pair will be 1. Okay, it will mix the next oxygen will have 2 lone pair, 2 bonding pair, and it is opposite to this possible structure. That is resonance. And it is not necessarily that all molecules have only 2 resonance. It can have more than that. Okay. Another example of a molecule that have resonance structure is the ozone, O3. Okay, it can be drawn in two ways. It's either the double bond. If let's say we numbered them, this is oxygen 1, 2, and 3. 1, 2, and 3. The first possible structure is when the double bond between oxygen 1 and the middle, the center oxygen, the central atom. And the second possible structure between central oxygen and oxygen 3. Okay, and when we draw the resonance structure, we have to have this resonance arrow. Okay, if we draw these two, okay, actually, okay, neither structure that are correct. Okay, not any of these are correct to represent ozone, but it can be drawn to represent a structure in which the actual structure is the hybrid of two. Is this the mixture of the two structure? Then we say that it is a resonance. Okay, in which the resonance, the repetition here, the resonance structure have the same placement of atom, but different in the location of the bonding and non-bonding electrons. Okay. So another example of the molecule that have a resonance structure is the nitrate. Okay, let's try to draw the structure of the nitrate ion. Okay, so this is the nitrate formula, NO3 minus. Okay, when we calculate the total valence electron, okay, the usual step that we follow when we want to determine the Lewis structure is we calculate the total valence electron. Then don't forget to add 1 because this is the positive one ion. Okay, so total number of valence electron will be 24. Okay, 24 valence electron. Then we do the atom placement, the same method. Nitrogen will be central with 3 terminal oxygen. Okay, so we have formed 3 bonds. So we have used 6 electron in bonding. So minus 6, we have another 18 electrons left that to be distributed at 3 terminal oxygen. So they are all achieve octet. Okay, and then from this structure, we observe that only terminal atom oxygen that achieve octet, but not the central atom of nitrogen. So to make nitrogen also achieve octet, it's either, okay, this electron, okay, used to form a second bond with the nitrogen, between oxygen and the nitrogen. So if this oxygen that form a double bond with the nitrogen, it will make this oxygen have less, okay, have 4 or 2 lone pairs left, okay, after this one used as a bonding pair. Okay, it is also possible if this oxygen that use its lone pair, one of the lone pair, to be shared with the nitrogen and form second bond with them. Or it is also possible if this oxygen is the one that form a double bond with the nitrogen. So since that there are 3 possible, okay, structure, then we have to draw all. Okay, so the possible one, the first one will be nitrogen, double bond with this oxygen, single bond with this, and single bond with another one. It will make this oxygen now only has 2 lone pairs. Okay, whereas for the other 2 oxygen will have the first oxygen has 2 lone pairs. Okay, second and third oxygen will have 3 lone pairs. Okay, when they form a single bond only. Okay, and if the double bond is here, okay, it will make nitrogen double O, single O, single O. Okay, so single bond, make sure that they have enough lone pairs, which is 3. And for the double bond, make sure that they have only 2 lone pairs. Okay, the dots is compulsory. No dot, then you will lose your mark. One structure, 1 mark usually. Okay, and then the third one will be N single single double O. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. As for this, only 4 electrons around oxygen, 2 lone pairs. Okay, and don't forget, okay, it is ion, so they have to be in bracket with the charge outside. No bracket, no mark for you. Okay, same goes with this. And since that they are resonance, okay, this resonance arrow also compulsory. Don't forget to have this. Okay, so this arrow is specific to show that they are all resonance structure of the nitrate. The resonance structure of ozone. Okay, and then this is the example of the resonance structure of the NCO minus. Okay, there are 3 possible structure or 3 resonance structure of the NCO minus, A, B, C. Okay, in which when we have more than one possible structure, we can decide or we can determine the best structure, the best resonance structure of that specific species, that compound or that polyatomic ion, okay, by calculating the formal charge. Okay, so we want to calculate the formal charge of all atoms here. Okay, since that we have 3 structure A, B, C. Okay, so we want to start with the first one. Okay, which is the nitrogen in the structure A. The formal charge calculation, we know that nitrogen has 5 valence electron, minus it has 6 unshared electron, plus 1 bond made, so that it is equal to -2. As for the carbon, carbon has 4 valence electron, minus with 0 unshared electron, plus with 4 bonds made, it is equal to 0. As for the oxygen, it has 6 valence electron minus 2 unshared electron plus 3 bonds made, it is equal to plus 1. Okay, just rewrite back the formal charge of all. This is -2, This is 0 carbon, and then oxygen is plus 1. Okay, and then calculate the formal charge in the second structure. We know that nitrogen has 5 valence electron minus 4 unshared electron plus 2 bonds made. So it is negative 1. And then the carbon, 4 valence electron. Okay, it has 4 valence electron, 0 unshared electron, and 4 bonds made. So 4 minus 4 is equal to 0. Okay, and then for the oxygen, it has 6 valence electron minus 4 unshared electron plus 2 bonds made. It is equal to 0. Okay, so you don't need to show the calculation unless the question asks you to do so. Okay, if the question just asks you to determine the best structure, then you have to show the formal charge of each atom as what I've done here. Okay, then we move to C. Okay, as long as they are correct. Okay, as long as the value of the formal charge are correct. Okay, nitrogen, we know that it has 5 valence electron minus 2 unshared electron plus 3 bonds made. So 5 minus 5 here is 0. Carbon, 4 valence electron minus 0 unshared electron plus 4 bonds made. Okay, it is 0. Let's continue with the formal charge calculation of the oxygen. It has 6 valence electron plus 6 unshared minus 6 unshared electron plus 1 bond, so that it is equal to negative 1. Okay, so now we want to determine the best structure. We have to consider 3 criteria that we have discussed before. Okay, 3 criteria of choosing the more important resonance structure. The first one is we look at to the one that have a smaller formal charge. Second is we have to avoid the same charge, okay, on the adjacent atoms. Okay, and then the third criteria is the negative formal charge should be at the more electronegative atom. Okay, negative formal charge should be at the more electronegative atom. I've even have show you the example here. Head to the second criteria, we want to avoid the same charge on the adjacent atom, means that atom sebelah-sebelah, okay, kita nak avoid charge yang sama. So in this case, there is no, since that we have only one charge, okay, one atom that have a charge, the rest are 0, 0 is considered as neutral. It is not the one that have a charge. Okay, so we can ignore the second criteria. And the last criteria, in order for us to decide whether A or B or C as the best structure, is the third criteria, in which the negative formal charge should be at the one that is more electronegative. So we compare here, in the structure B, negative 1 is at nitrogen atom. In structure C, negative 1 is at oxygen atom. Okay, so the negative should be at the more electronegative atom, which is oxygen. Okay, so we will reject B. So the best plausible or the best resonance structure for the NCO minus is structure C. Okay, if let's say you have to explain it, okay, decide or pick the best structure, so your answer should be structure C. Okay, and then you have to explain your answer. So the first one, okay, because the smaller formal charge are preferable. Okay, and then the second reason is because the negative formal charge should reside at the more electronegative atom, which is oxygen. Okay, so this is how you answer it in exam. Okay, another example of the molecule that have a resonance structure, that form resonance structure, is the benzene and also carbonate. Okay, benzene is the C6H6. Okay, C6H6, if we try to draw the Lewis structure of C6H6, starting from the number of electron that it has 6 carbon. So 6 multiply with 4. It will be 24 electrons. Okay, and then it has 6 hydrogen. So 6 multiply 1 equal to 6. Total will be 30. Okay, and do the atom placement. Okay, if you know, you have experience or you have met before this C6H6 benzene ring, you know that it is in a ring form. 1, 2, 3, 4, 5, 6. Okay, and then hydrogen distributed equally means that each carbon will have one hydrogen attached to them. Okay, all single bond first and then calculate the number of bond that we have made. Okay, start from here 1. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 bond made means that we have used 24 in bonding. Okay, so we have another 6 electrons left. And we observe that all hydrogen, all terminal atoms already achieve duplet. So this 6 needs to be given to the central so that central will achieve octet. So if we distribute the 6 electron equally means that each carbon will get 1 electron. However, still the carbon do not achieve octet yet. Okay, so for them to achieve octet, if let's say these 2 carbon need to share the 2 electron, form a double bond. Okay, and it will mix this carbon and this carbon share their electron, form a double bond here, and this carbon share the electron and form a double bond there. Okay. So if you look at to the double bond, it is actually at the alternate carbon. Okay, and in which it is also possible if the double bond is made between, okay, if we remember just now, each carbon has 1 electron, right? So it is also possible if this one is being paired with this. Okay, this one pair with this and this one pair with this, it will mix. Okay, we have the second possible structure of the benzene. Okay, to be like this. Okay, now the bonds are here. Okay, so there are 2 resonance structure of the benzene ring, C6H6. Yes.